All right, hello once again. This is Jeff Scott of Rankin Technical College. I've been going over the PDF online textbook, AppInventor2, Create Your Own Android Apps by Wolber, Abelson, Spertus, and Looney. We're working our way into Chapter 12, which was our Robot Remote chapter. Again, I'm prefacing this by saying that I do not have access to a robot, nor have I ever had access to a robot, so I'm just going over the project as though we did. So, it says, let's get to the really fun part, adding behavior for driving forward and backward, turning left and right, and stopping. Don't forget about stopping. If you do, you'll have an out of control, and that's a very funny joke. The next NXT component provides 5 blocks for driving the robot's motors. Move forward indefinitely to go forward, move backward indefinitely to go backward, turn counterclockwise indefinitely, where the right motor goes forward and the left backwards, turn clockwise indefinitely, where the left goes forward and the right goes backwards, and stop to stop both motors. As mentioned here, the move and turn blocks each have a parameter called power. You'll use a number block along with the other items listed in table 12.6 to specify the amount of power. The author recommends that you put in 90%, but they also say that if it's not enough, you can turn it up to 100%, which is full power. All right? So these are the things that we're going to work with in here. The forward button click, triggered when the forward button is clicked, of course. The move forward indefinitely to go forward, 90 for the amount of power. The backward button click for when the backward button is clicked. The backward indefinitely to move backwards, again the 90 for the amount of power. Left to move counterclockwise, 90 for the power. Right to move clockwise, the amount of power. The stop button, and the NXT drive 1.stop to actually stop the robot. So when you look here, this is the code we want. There's not really a whole heck of a lot of it. All right. In other words, you might look at this and go, yes, there is, but look, there's only one thing that's called for each one of these. So I want to do the forward button, so I'll do it just like they have: forward, backwards, left, right, and then stop. All right, let's come in and first of all, once again, let's collapse this block. In fact, let's move these down here toward the bottom. One right around here. Looks good. So first we want the forward and backward buttons. All right, and I guess they actually show them like left and right here on the screen too. So for the forward button, we want to call NXT drive move forward indefinitely with a power of 90. Oh, that's a math block we want in there. Now I'm going to try something. I'm not sure if this will work or not, but I'm going to duplicate this. See if this allows us. I thought maybe it would give us a move backward, but it doesn't. That's okay. We'll just get rid of that block. So that should be our forward and backwards. The NXT drive, move forward indefinitely, move backward indefinitely with 90 on each. So that's here, and that's here. All right, now we got to move left, which is counterclockwise, right, which is clockwise. These over both just a little bit. There we go. All right, so let's check at what we've done here and see if it looks correct. So we already checked the forward and backwards. Let's check the left to turn counterclockwise for 90 and the right to turn clockwise for 90. And those look correct. Finally, we want the stop, which is just going to call the NXT stop. All right. And I believe that's everything that we've been shown here. Again, as the author mentions, when the stop button is clicked, the stop button clicked event is triggered, so we call the NXT drive 1.stop block to stop the robot. As I mentioned previously, if the robot doesn't move but you hear a whining sound, you might want to increase the power to 100% for maximum power. And the last part of this that's discussed is using the ultrasonic sensor to detect obstacles. As it says, using the ultrasonic sensor, the robot will stop if it encounters an obstacle within 30 centimeters, such as in the obstruction shown with a cat there in the figure down below. You can use the NXT ultrasonic sensor, which we added as one of our non-visible components, to detect obstacles. It has two properties named bottom of range and top of range that define the detection range in centimeters. By default, the bottom is set to 90 and the bottom is set to 30 and the top is set to 90. The ultrasonic component also has three events called below range, within range, and above range. Below range, the first one, is triggered when an obstacle is detected at a distance below the bottom of range. For the second one, within range, that's triggered when an obstacle is detected at a distance between the bottom and the top range. And above range is triggered when an obstacle is detected at a distance above the range. So as mentioned, we'll use the ultrasonic sensor 1.below range event block to detect an obstacle within 30 centimeters. If we want to detect something within a different distance, we would just adjust the bottom of range property accordingly. And we'll use the NXT drive 1.stop block to stop the opponent, stop the robot. All right, so we want to do this when it's below range, so we want to call stop. As mentioned here, when the robot's ultrasonic sensor detects an obstacle at a distance below 30 centimeters, it'll detect the below range event, and then we'll call the NXT drive 1 stop block to stop the robot. All right? There's the below range right here. And we want to call the stop, which I think we already have right here, so I'm just going to duplicate it, pop it in there. If the robot doesn't stop, in this case, in the example, it said the cat may have moved away from the robot before it drew within 30 centimeters, so it can be a little hinky to work with. All right, after you get the application working and you've spent enough time to actually play with your NXT robot, you might want to try the following. Number one, vary the amount of power in the robot. Number two, use a color sensor to shine a red light when an obstacle is detected. Number three, use an orientation sensor to control the robot. Number four, use the Lego building as elements to physically attach your phone to the robot and create applications that make the robot autonomous. So, in this chapter, which was granted very limited, we talked about the list picker component to choose from a list of paired robots. We talked about the Bluetooth client component to make the connection to the robot. We looked at the notifier to display an error message. We used the visible property to hide or show different interface components. We used the NXT drive, turn, and stop components to drive, turn, or stop the robot. And we finally looked at the NXT ultrasonic sensor component to detect obstacles. That is it for this chapter. When I come back with the next chapter, Amazon Bookstore, there are two things that I'm going to do. Number one, I'm going to reboot the machine, so I want to see if I bring that up at least if the interface looks fairly decent. All right. And second, we actually will try to run it and see what happens. And I have probably, well, there'll be nothing, but we'll try it anyway.